look at number 12. And this should be review. And, uh-oh, did I get rid of the... Oh boy. Okay, here we go. So, for today, you're going to need the sum and difference formulas. And just a review on the sum and difference, you can't do a sum and a difference at the same time. So this actually is two equations. The sum equation is the sign on top. So if you add the angles together, you add the answers together. If you subtract the angles, then you subtract the answers. But cosine works differently. If you look at the cosine equation, if you add the angles, then you subtract the answers. And if you subtract the angles, then you add the answers. And then tangent is different than both of those. There are actually two signs you have to worry about. If you add angles together, you add the answers on top and you subtract the answers on, you subtract the answers on bottom. Then the opposite of that is if you subtract the angles, you subtract the top and you add the bottom. Does that make sense? Everybody understands that? Okay. So, look at number 12. Cosine of 105. Do we have a 105 on the unit circle? No. So we need to make one. How do you make 105? 90 plus 15, but we don't have a 15. 60 plus 45. So we could do 60 plus 45, or 135 minus 30, or 150 minus 45. There are lots of them. Doesn't matter which one you use. So I'm going to go ahead and pick the first one. So the cosine of 105 is equivalent to the cosine of 60 plus 45. Now this is a cosine sum problem. On a cosine sum problem, do I add or subtract the answers? Subtract. So I need to write it out. Cosine of 60. So you see, this is alpha and this is beta. So cosine of alpha is cosine of 60. Cosine of beta minus sine of alpha, sine of beta. Does that make sense to everybody? Okay, so now all we have to do is look at the unit circle and find those ratios and plug them in. So let's look at, there's 60 degrees right here. So this is the cosine of 60 and this is the sine of 60. So I can fill those in. 1/2 here times something minus root 3 over 2 times something else. This is 45 degrees. The x value is cosine and the y value is sine. So cosine is root 2 over 2. Sine is root 2 over 2. So if I multiply those together, I get root 2 over 4 minus, if I multiply those together, root 6 over 4. They already have a common denominator. So it's just root 2 minus root 6 over 4. And if the angle you're looking for is not already on the unit circle, your answer will be some form of this. It will have a root 2, it will have a root 6, and it will be divided by 4. The only thing that changes will be positives and negatives. They both might be positive or negative, or one positive, one negative. It just depends on where the angle lands. But if you look at number, say, 18, is 315 on the unit circle? Yeah, it's already there. So the answer is going to be negative root 2 over 2. What it wants us to do is prove that that's true using two other angles. Well, how do you create 315 degrees? 270 plus 45, that would work. Let's use a difference formula, though, because we haven't used one yet. 360 minus 45. Okay. So we're on the sine of 315. Sine of 360 minus 45. If you're using the sum formula for sine, and would you add or subtract the answers? No, the difference formula, sorry. The difference formula for sine. So if I use the bottom sign here, I use the bottom sign there, so I subtract. Sine of 360 cosine of 45 minus the cosine of 360 sine of 45. Well, if I look at 360, what is the sine of 360? 0. And what is 0 times the cosine of 45? 0. So this just cancels. Just turns into a 0. Unless cosine of 45 is infinity, which it's not. The only time you have infinity is with a tangent. So if you had like the sine of 360 and the cosine and the tangent of 90, that creates a problem. 0 times infinity is a little hard to do. So we don't need to worry about that today. We can cross that off. What is the cosine of 360? 1. So I'm just left with negative sine of 45. What is the sine of 45? Well, if we look at our chart, sine of 45 is root 2 over 2, and we make it negative, and we got the answer we knew it should have been. Okay? All right. What about 22? The sine of negative 165. How would you create that? Um, 360 minus 165 is not negative 165. I don't know how you mean 0? Is that what you meant? That would work. So the sine of 0 minus 165. I see what you're saying. Yes, that would work. Can anybody figure out another way to do it? Wait, do we have a 165? Oh, we don't have one. Sorry, that's not going to work. What's the difference between 360 and 165? What is 360 minus 165? We don't have a 195 either, so that's not going to work. Okay, sorry. You can set it up for positives and change the signs then. But negative and positive angles don't necessarily have negative and positive signs. Right? The angles might have negatives and positives, but the signs in the answers won't. Some of them will, but some of them won't. So that doesn't work. But we could set it up positive and then just change it all to negatives before we solve. So how do you create 165? So we could do 135 plus 30. So how would we create negative 165? Negative 135 minus 30. Now, there's a trick here. Is this a sum or is this a difference? It depends on how you set it up. Okay, I can write this same thing two different ways. I can say the angle negative 135 minus the angle 30. This is a difference. Could I change that so it's a sum? That would be a sum. How would that change my problem? Well, in the first one, it's a difference formula, and my angle is 30. In my second one, it's a sum formula, and my angle is negative 30. And they're both going to get you the same answer. Which one would you prefer? The first one's probably easier because we don't have to look up a negative angle. Although negative angles are just, they're really easy to find. Okay, so let's set it up, and then we'll worry about the angles. So I'm going to set it up as negative 135 is my alpha, minus my beta as 30. So this is a difference formula, and I'm using sine. So sine of negative 135 cosine of 30 minus cosine of negative 135 sine of 30. Well, I don't really like negative 135, but where does negative 135 land? Well, one way to do it, 135 is that much. So negative 135 would be the same angle in quadrant 2. One way to do that without too much thinking, positive and negative angles are always vertical from each other. Always. Positive 30 and negative 30 are vertical from each other. Positive 340 and negative 340 are vertical from each other. So if you find a positive angle that lands in quadrant 4, all you have to do is go straight up, and that's the equivalent negative angle. Okay? So if you go to 135 and you go straight down, you hit 225. So if I look at 225, the cosine and the sine are both negative root 2 over 2. So negative root 2 over 2 here, and minus negative root 2 over 2 here. Does that make sense to everybody? Okay. Now we need to look at the cosine of 30. So cosine of 30 is root 3 over 2, and the sine of 30 is 1/2. So times this by root 3 over 2, and times this one by 1/2. So the left side is negative root 6, and the right side is, well, I have a negative root 2, and a 1. Plus root 2, and they're both over 4. Does that make sense? And again, if the angle you're looking for is not already on the circle, your answer is going to be some form of that. Or it will be some answer that's already there. Okay, now for the fun stuff. So number 27 says, verify that each of the following is an identity. In mathematics, an identity, one definition of it is two expressions that have the same value. So this is saying that if you take the sine of 270 minus any angle, that is always equivalent to the negative cosine of that angle. So whether you put 10 and 10, or 30 and 30, or 180 and 180, no matter what you plug in, that equivalent statement is still true. So when you change the angles, the answers change. But they change on both sides, and no matter what number you plug in, it's always going to be true. So our job is to prove that this is always true. And it's super easy. And this is just preparation for some harder stuff we're going to do next week sometime. So we're looking at a difference formula for sine. So how can I convert this using the difference formula? Well, alpha is known, beta is unknown, but that's okay. We'll just plug it into the formula. Sine of 270 cosine of theta, plus or minus? Minus cosine of 270 sine of theta. Do we know any of those ratios? Well, 270. What is the cosine of 270? 0. And what is 0 times the sine of any angle? 0, so this crosses out. And then what is the sine of 270? Oh, wait, did I write that backwards? Oh, no, I'm okay. Nope, I'm okay. Okay, what is the sine of 270? Negative 1 times the cosine of theta. Is that what it was supposed to equal? Yes, so we did it. We proved it. It's all basically the same thing. So let's do 33. Well, no. Let's do 32. Okay, is this a sum or a difference? So if we subtract the angles, do we add the answers or subtract the answers? Add them because it's a cosine. So cosine of theta, cosine of pi, cosine of theta, plus sine of pi, sine of theta. Well, what is the cosine of theta? Well, on the unit circle, we go over to theta. Cosine of theta is, cosine of pi is negative 1. So we get negative 1 cosine of theta. The sine of pi is 0, and 0 times the sine of theta is always 0. Is that what I was looking for? Yes. And again, these are really simple. You're just practicing easy things because they're going to get harder in the future. So we're taking it easy on you today. Okay, I imagine you have plenty of time to finish this worksheet in class. Good luck.